The sun has gone absolutely berserk, and what we're witnessing right now is nothing short of extraordinary. Over the past 3 days, our star has unleashed a relentless barrage of solar explosions that has left space weather forecasters on the edge of their seats. We're talking about more than 40 individual flares erupting from a single monster sunspot region, and the most unsettling part, this solar fury shows absolutely no signs of stopping. In fact, scientists are telling us that the worst may still be ahead. Let me paint you a picture of what's been happening up there. Starting on February 1st, a sunspot region designated OR4366 began what can only be described as a marathon of violence. This wasn't just a few sporadic pops here and there. This was a sustained assault of solar energy being hurled into space with a frequency and intensity that has genuinely surprised even veteran solar physicists. 26 flares in just the first 24 hours. Let that sink in for a moment. That's more than one major eruption every single hour, around the clock, without pause. But it's not just about the quantity. The sheer power of some of these explosions has been staggering. 5 of those flares were classified as X class, which is the highest category on the solar flare scale. To give you some context, an X-class flare is the kind of event that can disrupt satellite communications, knock out radio signals across entire hemispheres, and send charged particles screaming toward Earth at millions of miles per hour. The strongest of these was an X8.1 flare that erupted late on February 1st. This beast ranks as the 3rd most powerful solar flare of the entire current solar cycle, and it's the strongest eruption we've seen from the sun in over 2 years. What makes this situation even more remarkable is that this sunspot literally appeared out of nowhere. Just days ago, AR4366 wasn't even on our radar. It was rotating into view on the eastern edge of the sun, and as it came around, it began growing at an absolutely explosive rate. Within a matter of days, this region ballooned to nearly 10 times the diameter of Earth. We're talking about a sunspot complex that spans roughly 80,000 miles across. To put that in perspective, you could line up 10 Earths side by side, and this sunspot would swallow them all. The magnetic configuration of this region is what scientists call beta gamma delta, which is essentially the most unstable and dangerous type of sunspot structure you can have. Imagine twisted magnetic field lines coiled up like springs under tremendous tension, just waiting to snap. And snap they have over and over again. After that initial wave of 26 flares, the sun didn't rest. The following day brought another 17 eruptions, 14 of which were powerful M-class flares. The strongest among them was an M7.2, which came dangerously close to crossing into X-class territory. Even more concerning is the 40% probability of another X-class flare. Those aren't comforting odds when you're talking about events that can cause strong radio blackouts and potentially dangerous radiation storms. And remember, we've already seen 5 X-class flares from this region in just over 50 hours. There's absolutely no reason to think it won't produce more. In fact, based on the behavior we've observed so far, it would be more surprising if it stopped now. Each new flare brings the potential for another CME. Each CME brings the potential for another geomagnetic storm. And all of this is happening while our technology-dependent civilization is more vulnerable to space weather than ever before. Our satellites are exposed, our power grids are susceptible, our GPS systems can be degraded, our communications infrastructure can be disrupted. This isn't science fiction or fear-mongering. These are documented effects that we've seen during previous solar storms, and with a sunspot this active sitting right in the crosshairs, we need to be paying attention. The space weather community is watching this situation with intense focus. Satellite operators are taking precautions, orienting their spacecraft to minimize exposure to incoming radiation. Power grid managers are on alert, ready to implement protective measures if needed. Airlines flying polar routes are monitoring conditions and may need to reroute flights if radiation levels spike. All of this is happening right now, largely invisible to most people going about their daily lives, but it's happening nonetheless. What makes this situation particularly noteworthy is the sustained nature of the activity. Solar flares aren't unusual. Active regions producing multiple flares over several days aren't even that uncommon. But the sheer intensity and frequency of what AR4366 has been producing puts it in a different category. Comparisons are already being made to historic active regions, including the famous sunspot that produced the Carrington event back in 1859, the most powerful geomagnetic storm in recorded history. Now, to be clear, we're not expecting anything on that scale from this event. But the fact that the comparison is even being made tells you something about how exceptional this sunspot region is. Looking ahead, space weather forecasters expect this heightened activity to continue through at least February 7th. That gives us several more days of elevated risk, several more days where AR4366 could produce another major flare, several more days where a new CME could be launched toward Earth. The uncertainty is part of what makes this challenging. We can see the sunspot, we can measure its magnetic complexity, we can watch the flares in real time, But predicting exactly when the next big eruption will occur, or how powerful it will be, or whether it will launch an Earth-directed CME, that's still beyond our current capabilities. What we can say with confidence is that this sunspot region represents a clear and present threat to our space environment. The question isn't whether there will be more eruptions. The question is how many, how powerful, and how directly they'll affect us. Every forecaster I've seen commenting on this situation has emphasized that AR4366 remains capable of producing another major flare at any time. The magnetic energy is still there. The complexity is still there. The volatility is still there. So where does that leave us? We're in a waiting game, a watching game, monitoring the sun hour by hour, waiting to see what AR4366 does next. Will it produce another X8 class monster? Will we see a more direct CME hit than the one currently headed our way? Will the aurora shows exceed expectations? We don't know yet. What we do know is that the sun is reminding us, in no uncertain terms, that it's the dominant force in our solar system. And when it decides to throw a tantrum, all we can do is watch, prepare, and hope our technology can weather the storm. This solar flare marathon isn't just a scientific curiosity. It's a real-time demonstration of the dynamic, violent, and sometimes dangerous star that we orbit. For the next several days, AR4366 will continue to command our attention, and space weather forecasters will continue their vigilant watch, ready to sound the alarm if this remarkable sunspot decides it's not done making history. The explosions will continue. The impacts will continue. And somewhere up there, on the roiling surface of our sun, a monster sunspot keeps churning, keeps erupting, keeps reminding us that, in the grand scheme of things, we're all just passengers on a small planet trying to survive in a very energetic neighborhood. Each of these flares has sent waves of radiation washing over Earth. When they strike our atmosphere, they ionize the upper layers, disrupting radio communications. We've already seen multiple R2 and R3 level radio blackouts, particularly affecting regions across the Pacific, New Zealand, and parts of Australia. Aviation crews flying polar routes have had to deal with communication difficulties. Maritime vessels have experienced interference with their high-frequency radio systems. Amateur radio operators around the world have watched their signals fade into static. These aren't minor inconveniences. These are real-world impacts affecting real people trying to communicate and navigate. But the flares themselves are only part of the story. What really has space weather experts concerned are the coronal mass ejections, or CMEs. These are massive clouds of magnetized plasma that get hurled off the sun during major eruptions. While flares travel at the speed of light and hit us in about 8 minutes, CMEs are different. They're physical material moving through space, and they take days to reach Earth. The X8.1 flare was accompanied by clear signatures of a massive CME launch. Analysis of coronagraph imagery shows dimming in the corona right where AR4366 is located, which is a telltale sign that billions of tons of solar material got ejected into space. Early modeling suggests this CME will reach Earth around 11 p.m. Eastern Time on February 5th. Now, here's where it gets interesting. The models are indicating this might be what's called a glancing blow rather than a direct hit. The CME appears to have been launched slightly to the side rather than straight at us, but even a glancing blow from an eruption this powerful could trigger significant geomagnetic activity. Forecasters are predicting G2 to possibly G3 level geomagnetic storms, which means we could see aurora displays pushing much farther south than usual. We're talking about the potential for northern lights visible across the northern tier of the United States. Places like Washington State, Montana, North Dakota, Minnesota, Wisconsin, and Michigan could all get a show. Parts of southern Canada and northern Europe are also in the viewing zone. The peak viewing window is expected to be between 10 p.m. and 2 a.m. local time on the night of February 5th into the early morning hours of February 6th. Of course, that's assuming the magnetic field in the incoming CME turns southward when it arrives. If it does, we could see some truly spectacular aurora displays. If it stays northward, the show might be more subdued. But here's what really keeps me up at night. AR4366 isn't done, not by a long shot. This sunspot is still facing Earth, and it's going to remain in an Earth-facing position for several more days as the sun rotates. The magnetic complexity that drove all these eruptions hasn't simplified. If anything, new intermediate spots keep appearing within the region, adding more instability to an already volatile situation. Solar forecasters are currently giving us a 75% probability of additional M-class flares over the next 48 hours. That's a 3 in 4 chance that we're going to see more powerful eruptions.